Hi there, AP Calc students. Our last online lesson from Chapter 3. Again, some more derivative rules, this time with exponential and logarithmic functions. So, first of all, we'd like to kind of derive one of these formulas here a little bit. We haven't done that for a while. This one's not too bad. So we'd like to actually figure out what is the derivative of e to the x. Now, this function e to the x is quite an important one in mathematics. E is an actual value, it is a number, but e represents, has something to do with natural logarithms, of course, and it also has a lot of practical applications that we'll see later. Right now in this lesson we're just learning about the derivative rules and stuff, but we like to figure out what this derivative is. So again, if I use my definition here, remember, which is the limit as h approaches 0. Remember, you're going to have to do one of these on our upcoming test, and that's to find the derivative by the definition. So this is, again, a little bit of a rule of that. And remember what that was. Once again, it was the f of x plus h minus the f of x, and all of that over h. That, again, according, or as the limit, or as h approaches 0. Now, applying it to this problem, you see that we're going to have the limit as h approaches 0. And basically, remember, I replaced that x plus h in place of x. So then it's going to be e to the x plus h power minus e to the x, all of that over h. Now, something you may or may not remember from your algebra days here is this e to the x plus h. When you have an exponent raised to a power like that, especially something that is added, you can actually write it like this: e to the x times e to the h. And then I still have my minus e to the x like that over h. Now, what you probably can notice here is that now in this expression up here I have a common factor of e to the x. So like we've been doing from time to time, I can actually pull that out. So I have e to the x, and then in parentheses e to the h minus 1, all of that over h. Now at this point, and we have seen one or two like this earlier, here we have the limit of a product. So really we could write it as this times this. So I'm going to do that at this point. So I have, and actually if we think about it, the limit as h approaches 0 of this e to the x, that's not going to have any effect on e to the x because there's no h value, of course, in this expression. So it's actually going to be just plain e to the x times the limit of what's left here as h approaches 0 of e to the h minus 1 over h. And we didn't emphasize this a lot, these different properties of limits, but the idea here is that if you have the limit of a product, it's going to be the product of the limits. We already said that the limit of e to the x as h approaches 0 has no effect on e to the x, so that's just going to be e to the x. And actually, what we would find out here, we can't really do too much more with this expression right here, but if you did graph this out, we would see that this whole expression here is actually going to be equal to 1. And beyond the scope of this class to be able to do that algebraically, we could just graph that and see that that's the case. So notice what we end up with here in this case is that my final answer is going to end up to be, I'm going to change pen colors here again. Maybe I'll go to this. And is just going to be e to the x times 1, which is just e to the x. So interesting, the derivative of e to the x is the exact same thing, e to the x. And we'll make use of that quite a bit. Next slide here just has all the different rules in this lesson here, so I would just probably pause this video, take some time and write all of these down. So basically we have ones that deal with e's or powers here in this case, in this column here, and ones that deal with logarithms over here. Now, you might be a little bit rusty, especially on logarithms, but we'll touch on them as we talk about these particular derivatives. Again, the basic idea, as we just proved, the derivative of e to the x is e to the x. Now, if that exponent up there, remember, is something else other than x, then we also have to take the derivative of that, as per the chain rule. Same thing here, if we have just a plain old exponential thing up there, and then we have to apply some logarithmic rules here. We'll see how that works in class. And here's another one that's definitely worth memorizing. The derivative of ln. ln is called the natural logarithm. It has a base of e. The derivative of that natural logarithm is just 1 over x. But of course, if that is something else other than x, then we have to multiply by du over dx, in other words, the derivative of that. There's that chain rule once again, as we see in action in these two different formulas. And we have a different type of logarithm, log, that just has a different base, and here's the formula for that. That's a little bit more complicated. So I'll write this down, and we'll just take some time here and look at some easy examples on the next slide. Alright, so first one we want to take a look at is e to the 3x. And so if we're trying to find the derivative of that, we remember that the derivative of anything to the e power is just the same thing, e to the 3x. But then I'm going to multiply it by the derivative of my exponent, which in this case will just be 3. So my final answer here then will be 3e to the 3x. Again, kind of that chain rule in action there once again. How you doing, Joe? Want to say something to the calculus students again?
I'm a Hulk.
Yeah, you got a green face today, don't you, Joe?
Yeah.
So you are the Hulk.
Yeah, thank you.
All right, sounds good. See ya. All right. All right, that was our special guest again. Joe, he was also a guest in a pre-calculus video, I think, so nice to have him here with us. All right, next one is the ln of the square root of x. So let's take a look at this one. Now, anytime we have that ln, that natural logarithm, you might remember that it's going to be 1 over whatever that thing is. So 1 over the square root of x. But now we have to find the derivative of this expression. We have to do that if it's not just a plain old x. Now, remember, we've seen this a few times, that you can write the square root of x as x to the 1/2 power. And so what is the derivative of x to the 1/2? Well, it is 1/2 times x to the negative 1/2 power. Now, that looks a little gunky, but let's see if we could rewrite this again a little bit. Here's my 1 over the square root of x that we had before. Remember, x to the negative 1/2 will also be a square root, but it will be in the denominator. So we really have my 2 in the denominator and another square root of x in the denominator like that. Plus, let's see, I don't think we have any other negative sign or anything like that. I don't believe, do we? Let's think about that a little bit. Nope, I don't think so. So anyway, there's an answer. Now you do notice that looking at my denominator here, I can even simplify that a little bit. The square root of x times the square root of x is the square root of x squared, which will end up to be just x. So I believe my final answer here will just be 1 over 2x. Just make sure to get that x in the denominator, as you can see there. Alright, and my last example here, here's one of these logarithm ones, and this has a log with a base 5. So again, just following my formula here, I get 1 over, and then I put my x squared next, that's the actual function, and then it's the ln of that base, like that. But finally I have to multiply by the derivative of x squared, which will just be 2x. And so simplifying this a bit, I will have 2 over x ln 5. notice that one of these x's was able to cancel out. One's in the numerator, one's in the denominator. So there's your answer right there. Now, that's 3 pretty easy examples. We'll definitely go over more of these in class, but that should be sufficient for now, I think, to give you a little bit of background on these exponential and log derivatives. So again, just congratulate yourselves for making through this first unit. We haven't got to our test yet. We got a few days to get ready for that, but this is all the new material we've done anyway. And so even though it may not have always seemed that way, you guys have definitely changed yourself for the better via derivatives in this chapter. Thanks for watching, and we'll see you guys in class.